Next up, I get to also introduce another good friend and colleague, Zhamak Dehghani from Nextdata. And Zhamak was the inventor of data mesh, the notion, the practice, working through all the details of how does this apply in enterprise. And of course, this term has become very worldwide, phenomenally popular, but also interpreted in so many different ways. Over the past year, I got to consult for Zhamak and for Nextdata, and I understand about what their team has been working with some of the world's largest organizations, the complexities that they're working with. And I also want to draw a through line for one of the main themes that we're talking about here at the conference. Listening to what Sebastian was describing earlier this morning about digital transformation from SAP R3 to SAP S4, that in itself is an enormous piece of work. But really, the subtext there was just, they hit the ground running so fast, literally within a space of months, going from zero to having production use of AI. One of the biggest problems they had was actually getting data out of their organization. And I've seen this before in other enterprise. And also, we've heard this from what Lula was describing and really understanding the phenomenology of this, but also what Tom was talking about earlier as far as the need for understanding in each domain what specifically, how do you pull the data out of the organization to be able to feed AI. This is the area that Zhamak has been pioneering and is the world expert in. So please join me in welcoming Zhamak Dehghani.
Hi, everyone. Thanks, Paco, for the introduction. I'll get my clicker. So how many of you have heard of data mesh or used it or applied it? One hand went up. Oh, okay, a couple of hands. Okay, so there were a couple of, actually, maybe one slide back, there were a few words that stood out in the previous talk. The data is disconnected. We move it around, but it yet remains disconnected. It lacks context. We get the data, but we don't know how it was created, where it was created, what was the context within which it was created. So hopefully, by the end of this talk, you have some answers in about an architecture that can facilitate a context-aware, connected, yet decentralized way of managing data to feed machine learning models through RAG or traditional flows. If you want to learn more about data mesh, there's a book, and if you squint, there are some codes that get you to O'Reilly platform for free for a limited time to get to those books. Okay, what does the data supply chain look like in many organizations today? Like this. The data begins its journey on the left-hand side with the hope that it turns into some form of value in terms of applications, autonomous agents, recommendation engines on the right-hand side. And between this is the data supply chain. We have the concept of pipelines that get really unruly and large and complex to move and transform and cleanse data. We have the context, or I guess the stage of storage and compute, so we can connect that data together, we can put it in one place, we can get meaning out of it. Unfortunately, that's not enough. And then we realize, oops, we lost the context about it. We don't have the metadata about this data. So we have technology that try to, after the fact sometimes, to gather the metadata about the data and layer it in. The knowledge is missing. So what are the business concepts and the relationship of those business concepts that now have been lost in this unstructured, semi-structured data, semi-structured or structured data? We've got to layer that in. That's not enough. We've got to govern the data. So a set of policies that need to be applied to the data, a set of quality rules to make sure that the trust is established with that data. And then finally, we have some way of getting to it. So catalogs and search tools and so on. And I haven't even drawn the rest of this supply chain that takes you further into the dashboards or into the machine learning training flows. But I would argue that this is, while this looks pretty and rational and logical, it's actually broken at scale. In the middle of it, there is this idea that there is a centralized data team is in charge of this managing supply chain for all of the domains. And as organizations become larger, the number of the sources on the left-hand side grows, and the types of applications proliferates on the right-hand side. That centralized approach to data management becomes a bottleneck. And it takes days, weeks, sometimes months to go from a hypothesis on the right-hand side to answer a new question about your data to actually finding and getting to the data that can answer that question. And ultimately, the most important piece in my mind is that the trust gets lost. The person that has the context and producing the data on the left-hand side is disconnected and is far removed from the person that's trying to answer that question on the right-hand side of this diagram. Data mesh was really an antidote to this problem of managing data at scale as organizations grow. And yes, the bottom line is that this problem is not going away. It's only going to get worse as the number of the data sources will grow, as the application of LLMs become more pervasive in organizations. If we imagine, data mesh really came at this inflection point. It was introduced to solve the plateau problem on this graph. As your organization, the sources of the data, the complexity of those sources, complexity of use cases grow, how can we remain or even accelerate the speed of innovation with data? How can we come up with a logical architecture that can do that? And there were really fundamentally 4 principles behind it. Then the principles were trying to invert this or transform this data management from a pipeline to a network. The 4 principles are around, first and foremost, how do we scale our businesses? Today, we introduce new business domains, and then we connect them to each other, right? They interact. So but fundamentally, it's a graph structure at a macro level organization. So why don't we create the data supply chain ownership and responsibility and push it into the business domain? This example is a hypothetical example of, let's say, a business like a Spotify. You have people that are dealing with partners. You have folks in your business domains that are working to create intelligent and context-aware playlists. You have folks that are building the actual channels of getting music to you. So why shouldn't those people be responsible for the full end-to-end data supply chain for providing data in a consumable way as a product to the rest of the organization? And then, of course, we have other problems to solve because those people really are not data engineers, and we have to create an interface or set of tool or infrastructure that allows them for domains to have the ownership of their data supply chain. That can very easily and quickly lead into data siloing back into the domains. So we have to come up with a new paradigm, new concept that really treats data like a product that you share and is consumable and easily manageable across the boundaries of ownership. And governance is a big issue. So if we are federating ownership of the data, the governance needs to be addressed. So data mesh tries to address all those concerns. But to get there, it's actually really hard work. It's easy to say we have these first principles we can work from and decentralize ownership of the data, and there's yet another thing to make it a reality. So the thesis of Nextdata has been that for us, this data supply chain makes sense. These steps must exist. But to decentralize this process, we need to get thin slices of this full supply chain around the concept of the domains and data products within domains, and package this data supply chain in a way into some form of a containerization. The same way that we went from monolithic business applications to kind of microservices, and the only way that was possible was containerizing these small applications and putting APIs around them. It is a similar analogy. So we need to containerize how the data gets produced, what constitutes data, the data model, the policies that govern that, and manage that as a single artifact in a way that hides the complexity that's really under the physical layer end to end, and package that around business concepts. So you might have data products around online sales, you might have data products around return on investment, you might have data products around your manufacturing, and so on. And these data products can be connected together. So what? So that you can scale, so that you can have your cake and eat it too. You can grow, but move faster and innovate with data. It's a system of scale, right? Graphs, networks, scale often really well. And get to the point that you can generate these data products, get to them, discover them, use them in a matter of minutes, not a matter of weeks, not a matter of months. What could such a system look like? This is one approach to implementing it. An approach that we have taken is really we have created these logical constructs at build time and run time that still runs and uses and manages the underlying infrastructure that you already invested in and have. So it delegates the compute, it manages the full pipeline, the code that's producing a particular domain or nodes on your graph of data mesh. It manages the code. It runs the code on the compute of choice. So, of course, Databricks, Snowflake, whatever that compute is. It manages the data and metadata that gets produced as part of running that and manages that on the underlying storage. Policies that need to be governed, the API, and you can get to that data through APIs, get to the underlying data, and have APIs for managing its life cycle, controlling it, and discovering it. So that's one approach that we have taken in terms of creating an architecture that can scale itself out over time as you bring in new business domains, as you bring in new sources or applications. There are two cute side effects when you think about your data supply chain from a domain-oriented and bottom-up perspective, and you put the semantic of the data first. One of the first artifacts of that data product is, what is the semantic of this data product? What is the semantic of online sales? What is the semantic of return on investment? What is the semantic of manufacturing? This example is a semantic of actually a pharmaceutical company that we worked with, is that you locally define the semantic, but you create in that local definition, you create connections or links to adjacent data products in that network. One of the problems that we know about and we've tried to solve for decades is master data management. That one concept, when it crosses the boundaries of business, it shapes changes. It is the same concept, but it shows the different facets of that concept. So in this pharmaceutical, for example, the concept of the drug, at the time of discovery, it's a bunch of compounds, right? It's a chemical compound. When it goes to clinical trials, it still has a generic name. It's represented by a generic name. When it goes to manufacturing and productions, then it gets its commercial name. But it is the same drug. And how do we know it is the same drug? So in the data mesh world, you define the concepts. You don't try to define a drug that constitutes all of those definitions. You're very domain-oriented within the clinical research. You define as compounds and so on. But you have the ability to link these semantics together because that's the semantic linking is part of the API of your data product containers. Similarly to lineage part of your data product APIs is where the data comes from and who's going to come and how would I get that data. And by linking data products together, you can establish a emergent lineage of your data, even though that it crosses physical boundaries of storage, physical boundaries of compute, we can create that logical layer. Another kind of wonderful side effect of this paradigm that we have tested with is that the new models of whether you're fine-tuning or with RAG, enhancing the context of your AI applications, rely on incremental and again domain-oriented or subject matter expert incremental of fine-tuning. Imagine again, we go back to the Spotify world and imagine you have a LLM-based agent or a chatbot of some sort that it answers intelligent questions. And one of the new types of questions that perhaps people want to ask is, what song should I be listening to? So the very first step in solving that problem is figuring out, do we have any data about song similarities, which is a very particular domain. It's different from other information about songs or listeners and so on. So we can think about that. Either we do have that, so you can search your mesh and find out through the metadata that emerge from your mesh whether you have song similarities or not. And if you're not, you will create one. But the beauty of it is that once you have song similarity as a semantic and domain-oriented concept, that data can be represented, managed, and shared in different forms. So maybe that song similarity can get used in a relational form, a SQL form, can be used in Parquet files as traditional ML training, feature engineering, or it can be used as embeddings for feeding, for RAG flows, and so on. So again, the beauty is that you are thinking about your domain first, and then the technology and physical storage second, and these are two layers that build upon each other. And at the logical layer, you are managing all of the supply chain, all the components goes into producing data and discovering and learning and trusting it into one domain-oriented logical component that gets versioned together, that gets managed together. I know there was a lot from what data mesh roughly is and how it might be implemented and implications of that. If there are any questions, I'm happy to answer now. And if you would like to see this in action, you can get in touch with me at hello@nextdata.com.
Thank you. I have a question is from industrial AI point of view, currently there are a lot of industrial IoT solutions, and the data is a streaming of the data. So how do you do the ingestion of a streaming data in your Nextdata structure so that you can harness the actionable intelligence?
Great question. The data, so I think it's very helpful if we think about the physical layer where the movement of the data and storage of data happens separately from the logical layer. And each of those are optimizing for a different problem. So in the physical layer, so we don't actually flow data through the containers. We manage where the data shall be flowed from and where we should get that data and what compute do we need to provision to process that data, what sort of guardrails we need to put around that to make sure that data is complying with some sort of policies and so on. So we manage that at the logical layer. At the physical layer, your data is still being ingested through queues or the protocols that exist. So I think, and they're stored in storage that is suitable for that type of high throughput, tiny, small streams of data. The way we manage that is that you specify a particular domain that is requires to tap into a particular stream of sensors and apply a certain logic to it so that you can aggregate perhaps that sensor around a particular, let's say you are calculating sensor downtime or clusters of sensor downtime, something along those lines. So that data product at the logical layer is configuring where it should get its data. It is the streams that perhaps already exist. It's configuring what is the code that is aggregating that sensor data. It's configuring where that sensor data gets stored. And in addition to that, so it manages all of that as one logical component. And then there's a value add on top, which is articulating or specifying declaratively what are the guardrails around that data. What is the quality metrics you're looking for? What are the data model validations that you're looking for? And also it validates that semantically how you describe sensor downtime, all the parameters that constitute that is actually matching what's physically being written to your storage. So I think the concerns of a physical layer are often the speed and cost, size, volume. That problem of scale we have already solved. There's technology that solve that. I think the scale problem that we haven't solved is when it comes to users trying to build systems on top that are domain-oriented and distributed across different business units. How do we go from that physical layer to the decentralized experience? And that's the logical layer we introduced. So we don't actually flow the data through the system. We flow signals about the data through the system so we can inject extra validations or policies or metadata that is being produced. I know it's a little bit mind-twisting to describe it.
So this makes perfect sense for within one organization. When we're trying to extrapolate this for cross-organization collaboration, obviously there's other things such as data retention and then data sharing policies that need to get established, which can take weeks. How does this kind of expand beyond the walls of a singular enterprise?
Yes, great question. I think the boundary of control and boundary of ownership, even when we squint out within a single enterprise, sometimes those boundaries exist. So the way we have thought about it is that every data product will have its own kind of self-contained, autonomous information that it needs to be able to autonomously perform. And as part of its interface, whether it's communicating its functionalities, data, or whether it's receiving controls in what policies need to have, has a set of APIs. So we think about this kind of if you apply your mesh at a global level, there are certain APIs that need to be available at an internet scale globally. And those APIs around the control of your data products and how to get to the actual data, and how would I discover and how do I understand it. So I think the very first step is defining those APIs and making those APIs on internet scale. What I would say, though, that we haven't solved, and I hope other people in the physical layer will solve, is the actual cost of data movement and where does the compute across organizations happen. Because right now, any cross-organization collaboration, privacy is one problem, but it's the cost of egress and ingress and moving data around is a big problem. And it would require data movement before you can put compute on it in your own environment. So I think what we hope to happen, which we haven't implemented yet, is your APIs for data sharing extend to receive compute to run on the data wherever it is, based on the policies of that data product owned by the data product. So by inverting what moves, data doesn't move, the compute moves, the control stays with the owners of the data, and that ultimately solves my data got out of my hands, so I don't know what to do with it. But that's I would say it's more of a vision of hopefully where we can get to.